Good day, everyone. Today we want to look at loan amortization. When you take a loan from a bank and you have to pay it off over a period of, say, 2 years, 3 years, 5 years, we want to see how the payments will be structured. We want to see what the installment will be. We also want to see the interest payments. And we also want to take note of how the loan balance would be reducing, how much would be paid in terms of capital, in terms of the principal per annum. We can only do so if we are able to construct an amortization schedule. But let's start off with a question. So that we apply it practically. Now, a loan of 300,000 Zim dollars is to be repaid over 6 years in equal installments, calculated on the basis of an effective interest rate of 16% per annum. Find annual installment to be paid, capital repaid, and interest paid in the first year and in the fourth year, outstanding loan balance at the end of the third year, the year in which the capital repayment first exceeds the interest. Now, for us to be able to work out that problem without any problems, we just have to list all the variables that we have there. After listing all the variables, we then calculate the annual payments, which are the installments. Then if we have that, we construct the amortization schedule. Now, the balance must be zero or very negligible if everything is done correctly. If everything done is correct, okay? If everything done is correct. Now, let's look at the variables that we have in that question. The loan amount in that question is 300,000. The tenure is 6 years. The cost of funds is 16%. And the repayments, we must actually take note of this. The repayments are annual, because there are instances when we have repayments being monthly. Now, if for instance this question requires us to pay monthly, we should be able to make some adjustments there on tenure. 6 months, 6 years, we turn that into months as well. This one, we turn this into a monthly rate. Okay, we turn that into monthly rate. Right, so that's that. Those are the variables that we have in that question. Let's just check. Yes, those are all the variables that we have. Now, next, let's calculate the annual repayment. Now, if the loan is 300,000 is given today, it means that the loan is in present value terms. Are we together? It's a present value. And it is going to be repaid by equal repayments, by equal payments over 6 years. It means those equal payments are annuities. So it also means, it also implies that those annuities are actually being received in the future, or are being paid in the future, and they are equivalent to today's 300,000, which means today's 300,000 is equivalent to the present value of those annuities. Okay? So the loan is the present value of those annuities, of those payments which are being made over a 6-year period at 16%. So the PV, which is the loan, is equals to the payments, which is the annuity, multiplied by the present value interest factor of the annuity for 6 years at 16%. Now, you know, we can say PV is equals to A, where A stands for the annuity or the payment, multiplied by that. So if this is the case, it implies that we can substitute, we can make PMT, we can make our annuity, we can make our installment the subject of the formula there, by just saying PMT is equals to the PV over the present value interest factor of an annuity. Now we can find the formula then for present value interest factor of an annuity, or we can also use the tables. Now it depends on whether the 16% is there on the tables. Now, how do we find the present value of an annuity if we want to use the formula? Now, present value of an annuity is given by that, is equals to the payment multiplied by 1 minus that whole thing all over R. So if we want to find P, we'll have to transfer the 1 minus 1 over that thing and over that thing to the other side. Now, if we transfer it to the other side, what do we get? So 300,000 is equals to PMT multiplied by that. We have substituted there. Therefore, PMT is equals to 300,000 over 3.684735,908. If we divide that, we get a payment of 81,416.96107. Now, let's try and make head or tail of this. Now, we now have the payment. We said our loan was a loan of 300,000. So there is 300,000. And we know that our interest per annum would be 16% multiplied by whatever is outstanding at the beginning of that particular period. So it's 16% multiplied by the opening balance, which means in our first year, our interest is 16%. Now, this must apply to everything. That's why I put I fixed that cell, the D2, where we have our 16% interest, which means if I drag there, unfortunately you won't be able to drag in the exam, but if you drag there, it means we would be referring the interest cell won't move, but this other cell would move. This other cell would be moving. So in the next year, it would be 16% of what is in C6. In that other year, it would be 16% of what is in C7, okay? Now, what would be our installment? We found our installment there to be what? Let's check from we found it to be this one. That's our installment, okay? Let's put our installment there. That's our installment there. But let's try and find the installment using other means on Excel. When we are finding the installment, we say it is equals to PMT, which is the payment, PMT multiplied by, we want the rate, the number of periods, you know it's 6, it's a 6-year loan, and the PV, what amount was given. The loan was 300,000. And let's put type 0 there. Let's see what comes out there, if we can be happy or not. Oh, okay, it appears the same, is it? So what we have there, it appears it is the same. Now this whole formula, we will have to say this cell is equals to that one, this one is equals to that one. The payment would be equal. So we just copy it there like that. That would be our installment per annum. Now, if that is our installment per annum, what would be the principal repayment in the first year? Principal repayment means the part of the capital of the part of the loan which has been borrowed, which has been repaid. Remember, the installment includes the capital repayment and the interest as well. So this means that principal repayment or capital repayment would be the installment there minus the interest charge, which means the principal repayment would be that. Now this formula would apply to every cell there, okay? So if that is the case, what would be our loan balance at the end of year 1? Now loan balance would be, I would like it to be like this. We put it this way. It is the opening balance minus what has been deducted from the principal. It is the minus the principal repayment, okay? Or it can be the opening balance plus the interest minus the installment, which is basically the same thing there, okay? It's the same thing. So if that is the answer, we know that as we begin year 2, the opening balance should be in that previous cell. Now if we drag there, would have copied those cells there. So which means opening balance for year 3 would be the closing balance for year 2. Opening balance for year 4 will be the closing balance for year 3. Same applies there and same applies there. Now, we did not copy this side. We said that one is opening balance minus the principal repayment. So this formula would apply for all these ones. Okay, so let's check. If you can check here, let me paint in a certain color what is similar there. That one yellow, this one, let's see, we have done it well. 227, like that. This one, we do it again like that. It's the same as that one. I just hope you are following closely. And that one also put green. And that one, see that one. Okay. And finally, our loan balance at the end of year 6 would be $0, which means our amortization schedule is the correct one. So if we just take this amortization schedule, we can take it, then put it on our slide there. That's our amortization schedule there. Now we have to answer the questions which have been asked in the as per our question. What has been asked? List no. The annual installment to be paid. First mark 81416.96. That is the installment. We just get it from our calculation there. Capital paid in the first year is 33416.96. Capital paid in the first year. Now, capital paid in the first year, it is this one, this amount there. That's the answer. And capital paid in the fourth year, it is that amount there. So it's 52,160. Is it correct? Yes. Then interest paid in the first year and interest paid in the fourth year. Now, interest paid in the first year, it's 48,000. That one. That's the interest in the first year. How can we write this one now? That's interest in the first year. And then interest in the fourth year is 29 something there. Okay. Then what else has been asked there? Outstanding loan balance at the end of year 3. At the end of year 3, the outstanding loan balance is that one. That's the outstanding loan balance. This one. This is the outstanding loan balance. This one. 182,853.50. Then, in which year what does the year in which the capital repayment first exceeds the interest component? The year in which the capital repayment first exceeds the interest component. Now let's check here. We don't want to guess. A year in which capital first exceeds principal repayment. Okay, we can do this. We can say equals capital exceeding, no, what is it saying? Exceeding interest. Yes, exceeding interest. Let's see. So in that year it's false, it's not exceeding interest. We can drag and see where we have our first true. Now our first true is in year, which year is this now? It's in year 3. Okay, so the answer to that is year 3. Answer to that is year 3. Okay, thank you so much.